Good evening and welcome to Steve's Place. It's Sunday, 6 p.m. and we should have a pretty good show tonight. Unfortunately, Bernard cannot make it, but we do have a lot of other stuff that we can cover, focused on plasma ignition. Anyway, and before we get started on the show, I just want to remind everyone we still have our video on demand available. Just click on the QR that will take you to the home screen. And what that would do is take to our home screen. And if you see this logo on there, you click on it, and that will take you to the sign up page right here for the DVDs. Okay, this year's video on demand for this year's conference. And it's $99, one-time fee, there forever. We don't have a time limit on how long it's going to be available. And we also have on the same page a donation button in the green. It's the green donation button there if you want to donate something for us to help us keep our operation alive and going and healthy. We appreciate it. That goes directly to TeslaTech. Anyway, we also have some T-shirts available too. You may want to order a T-shirt. Great Christmas gift, great design, and we also have two great designs. So click on the QR code, go to the homepage, look for the TeslaTech TV video on demand and for this year, and click on it, and it will take you to here. And let's move on to our YouTube channel. Our YouTube channel is extremely important to our operation. When we first started, I was kind of skeptical about it. I was highly resistant to it. But then I had a friend come over and actually set it all up. So here we be on YouTube, and we have over 1,500 DVDs at this time up there. We have had a few get censored or dropped by YouTube, and for whatever reason, primarily because they may mention things like the C word, and if you mention the H word, and also the V word, it's really strange. You mention certain words, and all of a sudden you get slammed pretty hard on YouTube, and so. But despite that, YouTube is the biggest video purveyor out there, and with that, we can take and get things that we can't get elsewhere, like referrals, And so I want to encourage you, if you're watching this on YouTube, be sure you click that thumbs up, because that's what drives referrals to us. So if you like the show tonight, click on it. If you happen to be watching other videos and you like them, click on it. Thumbs up, good for us, helps build our number. And so it also lets us know kind of where to go with our programming and that. And here's and to sign up for it, here's how you do it. You just go back to our channel. Just hit the QR. That should take you to our main screen, and on the main screen, TeslaTech.info, you can take and you can click on the TeslaTech channel, which will take you there, or you can just go there. If you want to watch a particular conference, you use our conference directory and go through that way. Like I say, we have over 1,500 videos up there now. A couple of them are 100 at least are free. If you subscribe, subscriptions are free. Subscriptions also drive our numbers up and helps us with our finances, and that we do get a little percentage off of the stuff, the advertising on the members only stuff. I'm starting to more and more not advertising, especially on the controversial stuff. That tends to keep the censors away from the really controversial material we cover. And it is our position that we're basically a fairly free speech as long as you're not slandering anybody. Don't make anything personal, and you can have facts to back you up. You know, and I'm talking about real facts, not stuff people just make up off the top of their head. But we do a pretty good job, in sticking to the scientific stuff. We are mostly hard science here, and we have a conference every year, which is basically a put up or shut up type of show. And so I encourage everyone to come to the conferences and see our hardware, because we are a hardware, not hot air kind of show. Anyway, if you decide you want to join, it's $9.99 a month on YouTube to have access to all of our stuff up there that we have on YouTube. We have all the conferences up to 2023, and I believe I only have a couple more of those to put up there. And then we'll start putting up other conferences as well. So, like I say, join us on YouTube. Now, I'd like to change gears here and kind of mention we also have a thing called the Kipper Motor construction notes. This is a motor I built. This is with Kipper. Kipper guided me. He's my mentor on this, and I've seen this guy do really, truly amazing things. We built that motor on your lower left. And with that motor, okay, when we built it, it took us all of about 2 hours to build. It didn't work on the first try with me because, like, when we hooked up the last wire, the motor itself just barely was able to turn that alternator, And so what we did is you can see here it's like a motor alternator, and then you have a little DC motor there, 3 amp motor. You get at Granger, the people get things done. Anyway, it could barely turn that, and so because the battery itself that we use, it was a dead battery. I mean, we pulled this off the junk pile and threw it up there just to have a battery there, and it barely was going, and you see how these wires are like all bunched together. Well, the amazing thing is when it started just going like, a Kipper gets in there and he starts taking and pushing these wires apart. He pushes the wires apart, and then all of a sudden it's like it took and it started going faster and faster and faster. And after I picked my jaw off the floor, because this should not have worked. What we saw the first time with the battery getting deader and deader, that's what should have worked. Instead, what worked is that this thing started going faster and faster. It's almost like the alternator was dragging that little motor around. But it charged that battery from like 9 volts to 14.5 volts in like 2 hours, And I go, Kipper, we got to take and do something here because this thing's going to explode, Because you can see the water's bubbling up, you see all these bubbles coming up. It's like crazy, And so he ran out to his truck, and he had a spare converter, AC converter in his in the truck. So he brought that in, and we cut the wires, stuck the inverter in there, put a 100-watt light bulb in, and figured, well, that should slow it down. And I'll be danged, it went faster. So, that's what made me a believer in a really true believer in free energy of the kind. I'm a believer, not by faith but of works, because I've actually seen it. I've stuck my hand in the side of Jesus, so to speak, a doubting Thomas type of believer, who who had to see it before he really believed it. And that's what has driven me ever since then. And for those of you who would like to see it, there's our schematic, and we have a parts list. Just send me an email at steve@teslatech.info, and I can send you out a PDF of this plans here. And it explains some of the things that our thoughts at the time. But the most important thing I got out of this, okay, is that even though we have a battery in the circuit, okay, even though there's a battery in the circuit, it used to be that people believed if you took away the battery, then and only then could you have a truly working free energy device. Well, I disagree with that now. I'm thinking with this thing here, we tapped in to another dimension. And the battery itself kind of serves as a chemical interface with another dimension. Okay, so with that in mind, when these people they show about these very, very simple things, start thinking about it with an open mind and not just strictly on your on our conventional electrical engineering training, because through electrical engineering convention, this design here, okay, should be a dead end. It should be doing nothing but dragging that battery down even more. The motor gets hot, and the opportunity was so big, the mass would absorb the heat. But I must say, like when it died in 3 weeks, that's what she noticed. First, the motor was very cold when it was running right. When it died, it got very, very hot, really fast. Now, with this a thought, let's move on to the next engine I want to discuss. This here is a GEET motor. Okay. That Paul Pantone invented. His son David's trying to work on continuing the work. I have one of these on a small engine, and I've seen it work. There's a couple of things to keep in mind. Like when this thing is running properly, the exhaust, which is on your right, looking at the screen, okay, the exhaust should not get hot when it's working properly. If it's hot, there's something wrong. When it's working, okay, what happens is the reactor, which is basically have the intake going through the exhaust, okay? And what happens is the heat combined with this rod that's in the middle with the magnetic field turns into a plasma. The heat you see on this should peak somewhere along the axis of the reactor. Okay, and that's that blue chamber in the middle of the screen there. Now, the reactor, where that is, it will vary based on the type of fuel you're using. Like the hot spot for the oil is going to be different than a hot spot, say, from coffee or Coke. So it's a variable thing on the reaction there. And one of the things they found is like when you have the intake going through that inner tube, there's a rod right in the middle of the inner tube. So you're going from a big space, okay, down to a very small space, okay? And you get things like the Bernoulli effect happening, and the one Ventrelli effect. Anyway, what happens also is you have a speeding up of the mass, okay, because you're going from a big area down to a small area, it speeds everything up. Plus, it's going over a surface. Okay, anytime you have a gas passing over a surface, or any material passing over a surface, you're going to have a electricity generator, which in turn generates a magnetic field, which kind of energizes the intake there of the fuel and turns it into a plasma. Okay, and the plasma kind of like you get like a twisting motion in the middle of this thing where it gets the hottest. It's like squeezing all the energy out of it. And when it comes out, it's going into that engine as a plasma, and that's what gets burnt. And that's how come you have practically zero oxygen, zero carbon and zero hydrocarbons, no carbon monoxide, no carbon dioxide, basically most oxygen, hydrogen, and some elements. So the plasma has a definite effect on combustion. A couple months ago, we had Tom Martins come in here, and he had his Martins device. Now, to me, the Martins device was quite unique. Here's what it looks like, the schematic. Okay, on the schematic, you can see basically it has a battery. Okay, charge, goes to the ignition coil, and then he has the air intake go through a series of spark plugs, and the air intake then goes out and is mixed with the fuel, with the injection, fuel injection. So what you have is a plasma mixing with fuel and then getting burned. Pretty incredible stuff happening here. Here, I was struck by the similarities to the GEET device. The GEET device, you have the bubbler taken and mixing the fuel with the air, okay, that goes into the intake, okay, and so it has like a plasma being created out of the air-fuel mixture. And with the Martin device, okay, it doesn't need that. It takes and turns the air into a plasma, and then I guess when it mixes with the fuel, it could turn around and make the air fuel mixture a plasma in itself. So it really simplifies the GEET device, I believe. That's one of the thoughts I've had. And in the meantime, here I'm going to put up our caller hotline if anyone would like to get in on the discussion here in person and maybe share their views on this stuff. I'd be happy to have you on here. In the meantime, we have a Terran Earthling, and he asks, it's like cold plasma? And I guess you could say, the thing about plasma, okay, is that back in the 1900s, they were all thinking, that to be a plasma, it had to be hot gases, to be a real plasma in that. This here turns plasma technology on the head, and And because everything's in a vacuum, anyone who works, with chemical reactions or actually any kind of reactions will find that things react at lower temperatures in vacuums. It's just a fact of life. Yeah. And so what will happen here, is you don't have to have the intense temperatures that they're looking at in these nuclear fusion devices and that. Um, I'd like to see more research get done, on this type of stuff. It looks like all these major companies, think they have a handle on anything. So if anyone has a thought on this could be a place where you can have a real input in our future. We need this kind of technology because I don't care what these people say. Global warming is here. It's going to get worse. It's not going to get any better until we start doing something to stop putting heat into the atmosphere in the amounts that we're putting. Unless the sun died, and then if the sun dies, we're all dead anyway. So anyway, we have Savage. He's just coming. He's still working on his Tesla turbine rotors and that. Maybe he'll come on later. Kind of like going through these notes real fast. This year we're going to have our conference in Albuquerque. I hope people show up to it. Even more people than last year. I like to be growing every year. I think this stuff is very important. I think it's important for the young people of our time, to get involved in this kind of stuff. Computational technology is one thing. Here, this is good hands-on stuff. It's like building a Tesla coil. It's easy to describe Tesla coils and it's easy to describe how to build them, but the trick is to make them work. And that's kind of like an art form in and of itself, and you gotta get real creative on the ability to tune stuff. That's the other thing I want to bring out on the GEET thing is here, the length of the rod. If you had a rod too short, you didn't get the reaction. If you put the rod in backwards, because the rod will be magnetized when we first start this thing up, it magnetizes the rod. If the rod, you take it apart and you put the rod back in backwards, you won't get the reaction. It's kind of like resistance, It's like throwing sand on an oil surface, or on an ice erosion. The sand, stops things from sliding. Well, you get the same thing out in reactions. Here, if it's in there right, it will be okay every time you start up. If you take it apart and put it in backwards, okay, it won't work, not because of the shape of the rod, but because the magnetic field on it is resisting the creation of a field. And the way out of that is you take like a degalloser, like if any of you are TV repairmen out there from way back when, sometimes you have to degauss the screen, to get it to work right, okay? And that's what a degalloser on this rod will do. It demagnetizes that rod, and then when you put it back in there, it's like starting it up all over from scratch again. And like I say, the one key thing on here that you could tell almost instantaneous whether it's working or not is the exhaust. If the exhaust gets hot, that's the muffler. If the muffler is hot, you don't have the reaction happening. Okay. Like I say, I've had one of these. There's a lot of things that are different. Like when you first start up the engine, okay, you'll have like, I don't know if you see these valves, off by the bubbler. Well, what you have to do is have a lot of oxygen coming in at first, and then as you start the engine starts running, you start cutting off the outside air, and by the time this thing is warmed up, the air intake that's on the bottom, okay, um, that could be completely off, and all the air should be coming completely through the bubbler into the source. And I think this one here, they were trying to do a little bit of closed circuit stuff. Okay. Like I say, this thing is very touchy, and I've had this here. The engine I've had it since, probably about 2010 or so, maybe earlier. So there's nothing in these things that will wear them out, really, outside of what normally would wear an engine out. Maybe every now and then you might have to replace seals in that, because the biggest impediment to getting this thing to work properly is the vacuum. If you have a problem, it's going to be because of a vacuum leak. Okay. And so, like I say, plasma, it's a growing field. It's a field that you can do at home, regardless of what anyone tells you. And if the GEET is really complicated, I think that that Martin's device here, which is patented, but I'm sure he'll be willing to collaborate with people, that to really build this thing up, is an alternative route to what Paul was trying to do with his GEET device. And the advantage that this device would have over the GEET device is the GEET device has a fuel line going through an exhaust, which, for safety reasons, mechanical engineers would really consider that a fire hazard. This, on the other hand, where you're sending plasma, okay, electrified air through the system, okay, is a totally is a different concept. But in both cases, you have a plasma going in to the combustion chamber, and it will have a different effect on the exhaust and everything. Okay, and here's a question here, a bit off topic, but can you explain the time you disappeared the ionosphere? Well, I didn't disappear. What happened was the United States government did. I believe it was in Operation Starfish, when they had an airburst nuclear blast in the South Pacific, and the ionosphere disappeared for a couple of hours. And there's a group, they were based out of Goddard, but what they would do, their job was to go around, and they do things like they're constantly monitoring the ionosphere and the health of the ionosphere. And when that disappeared, they definitely knew something happened. They didn't know that a nuclear bomb had just been gone, blew up down in the South Pacific. But it makes sense, because when you have like a nuclear blast and you have all those charged ions and that going through there, it's like short-circuiting two plates of a capacitor, So that's what happened there. That was in the early 60s. And I hope that we don't have any more surface blasts or air blasts, but I have a feeling that they're going to start happening again, as everybody wants to have their own little nuclear bomb, and that's given the fact that Ukraine, who doesn't have a nuclear bomb, they gave all their nuclear weapons away to us, okay, and to Russia. with a guarantee from the United States that we would take care of their security, you know. And now, given the nature of the war in Ukraine, how's that working out for you? So now everybody thinks that they have to have a nuclear weapon so that they won't be attacked by other countries. And so within the next year here, expect to see the nuclear race take right back up like it never stopped. Okay. Now let's see. Okay, and another thing says that it needs to run a little bit like every ion beam combustion. I'm not sure about that. You know, it just seems to I don't remember like that. I do know one thing: when we put in coffee, you know, coffee would run great, you know, but you had to have a little gas in there to start off. But after you get it running and everything, you don't add any gas to it. You know, I was constantly adding coffee to it. Let the thing run down to nothing, almost nothing. Pour more coffee into it. You know, and eventually you get to a point where there is hardly very little gas. So that worked. You know. Now I know when Paul was driving, I rode in his his car, you know, his Suburban, and he had converted to the GEET device. He has a thing that kind of replaces the air intake here. You know, this stuff on the right there, where you see the pipe with the green where you have air coming in. Okay. He had a thing called an air management. Actually, it would be on your left side where it says you have the air and you have outside air. Well, what happens with that is he has a thing called air management valve, which is like a carburetor with a choke on it. You know, I've seen some real creative people out there. In fact, I knew one guy from West Virginia. Didn't have a whole lot of cash to work with, but he knew how to carve, and he actually built a wooden air management valve there, which is pretty cute. And but he had to constantly adjust it when he was driving, and we're driving down the freeway between Blaine, Washington, and Seattle, and anyone of you familiar with the area knows how hilly that area is. You know, so you're speeding up and slowing down all the time. You know, so yeah. Okay. And I also noticed that there's a new motor coming to town called the Holcomb motor. I haven't had a lot of time to do a lot of research into it. But I went to the website. I'll put that up somewhere. Just write to me. But that website shows that these guys are very serious. I guess they went to court on it because they were advertising it as an over-unity device, basically. And they won their lawsuit. And it's really a big company. There's serious players in it. And I haven't been able to determine exactly what they were doing because they're kind of closed mouth about a lot of stuff and they don't give you a lot of information. Who knows? Maybe we can get them to come to the conference. If anyone knows of them or is in contact with them, that'd be the Holcomb Motor people. See if you can put us in touch with them. Okay. It says here, heat probably rubs molecules against each other, causing electrical friction. Well, it does. It rubs against each other, but more importantly, it's rubbing going across the surface of the rod there, and that rubbing across the surface causes electric current to be generated, or electric charge to be generated. And wherever you have electric charge, you also have a magnetic field. So, and anyway, here we have one. So, how is the hunt for the hotel for next year's conference going? Well, we're still working on it. I've been out for new beds, and I'm looking at what the hotels have to offer, but I'm also looking at an alternative to where we can get a really nice conference center and at a decent rate. And then we can also get go to like a lower cost hotel, where instead of like $120, $140, $180 a night, if we could spend a lot less, more like down in the 80s and 90s with breakfast, And so that's one of the things I'm looking at, We did this in Salt Lake City, and everybody had a great time, and we were able to get a lot of information out. And we had I catered the stuff myself, as far as the food goes, and we had lots of chicken, pizzas, and subs, So it was nobody lost anything. They just had a great time, and we had to just go from the facility to the hotel, which was just down the street. That's something I'm trying to do here, possibly. At least look into it and go back to the hotels and see what kind of prices that they're willing to entertain. My biggest issue is I don't need to be lectured on boundaries. One of the hotels, well, we need to set boundaries. I'm going, well, we don't need no boundaries, You should be talking about how to make our conference the most successful ever, not trying to, have boundaries. I mean, that's not what it's all about. Somehow they forgot that we're customers and not children. Anyway, here we go. Hey, they're talking about the airflows on the GEET engine again here. And the thing about the engine is you have a pipe inside of a pipe. And here he says it is using the heat of the exhaust to make the inside pipe and rod to 300 C, which allows the iron catalyst to release and crack the hydrogen, preventing the iron from saturating it. Well, possibly, but I do know that that it does create the plasma, and at a certain point along that along the reactor there, you're going to have a hot spot, and it's like like a rag, and you squeeze a rag, a towel, and you squeeze all the water out of it. That's kind of what it does in this reactor, and the energy is absorbed into creating a plasma out of a non-plasma material. So yeah, boundaries. See, I try to explain to these people, we're out here, to break the laws of physics, or rewrite them, but the boundaries is the anathema to what we're all about. And basically they just don't like us moving tables around and stuff, but that's one of the reasons, we don't have it in Vegas. In Vegas, you have certain rules you got to follow, and plus it's very expensive at most hotels, especially on the Strip. I mean, this town has become all about money. Uh, I remember when just a couple of years ago, about 3 or 4 years ago, you could get a hotel room for $28, And now they tore down um, four major hotels to keep the room rates to over $200 a night. You know, I mean, this is insanity that we live in today. It's all about the money, all about the Benjamin. You know, so okay. Anyway, we have Mike here. Don't count on me for chemistry or mechanics. Troubleshooting electric? Yes. Okay, good. Uh, my chem is halfway below average and my mechanics is worse. Well, I know next week we'll probably have Bernard here, and he could probably address some of the stuff we're talking about now. I know he's big into alchemy, which is converting different forms of energy. And I don't know if anyone of you was watching last week, but he had a jar of light blue liquid, and that really struck a, a, a tone with me, because I have some friends, and one of the things that they're doing is they're taking all this waste ore, or not ore, but the stuff you get from when you're processing ore, slag, and they're taking the slag, they're crushing it to a certain very specific grain size. They're cooking it, in water, for about a week, and they're taking and adding catalyst to the stuff, when they mix the pot together, and they keep it at a certain temperature, and there's no electricity applied to this thing whatsoever. But if you open the lid up, you see like a lightning storm inside of this device here, or inside their cooker, and that's the free electrons snapping back into orbit, their proper orbit. Because what slag is corrupted metal. And what this process does is decorrupt it. And when they do their RF analysis on it, right? When they first do it, it comes out zero. But once they go through the process, they have an incredibly rich product there, And the important thing to know about this is that it was like a light blue. When they take this mixture and they put it in a squeeze, and they squeeze out and just get the liquid's light blue, just like Bernard had. And when I saw that was the same color, I mean, and then what you do with that light blue liquid, okay, is they add precipitates to it. Now, I don't know if anyone here has ever had your water tested. It's something I did when I didn't have a job. When you had a job for selling water softeners. And what we do is we go in there with this little chemistry set, and we take your water and we add these chemicals to the water. And when you add the chemicals to the water, all of a sudden you can see the hardness drop out of it, like your lime and everything that's dissolved is going to drop out of this, and you end up with a test tube of clear water, and then the bottom half would be minerals, okay, or stuff that was in the water. And the water where I used to live at, in Queen Valley, well, you had to stand back when you turn on the shower, because big rocks would come out. Just joking. But boulders. But that water was extremely hard, it was like about a 40 on the hardness scale. And for comparison, a city, like if you live in an urban area, they come out to be about 6. Okay. They come out with on the hardness scale. So that's how hard the water was where I lived in. and you change the salt all the time on it because you use salt to take out the hardness. But here, so you have these precipitates, right? The chemicals you use to add to this blue liquid. And as you add them to the blue liquid, depending on which precipitate you use, okay, you're going to get gold, and you're going to get your silver, and you're going to get your precious, your like things like rhodium and platinums and that out of it. Okay, and that's all going to drop to the bottom of this. And usually the precipitate you use first is going to be what you get out mostly. I guess it depends on the blue liquid. But then you take that solid particle, okay, that dropped out of it, okay, you take that and you can form what they call a button. You take the button, and that's what you get assayed. Using they use an RF assay. And because they use the same type of assay, you can know that it's apples to apples and not oranges to oranges. So that is pretty much I have all to say right now tonight, unless somebody else wants to get on here. I did put the number. Let me get that power back up. Oh, here we go. Yes, sir.
Hi.
Yeah.
I showed you guys the last time I was working on my dual axle Tesla turbine, and have a little bit of an update if anybody's interested.
Okay, so how's your turbine coming?
Well, it's been going through a couple different iterations. I've been working pretty closely with Jeremiah, and he's been kind of guiding the design of the whole thing, really helping me out understand, nozzle and exhaust and the shape of everything, the proper dimensions and whatnot. So things have been evolving quite a bit. This is actually the second iteration here. If you can see that, this is just the housing and the nozzle and the exhaust. And that's evolved into something a little bit bigger. So this is the newest one. And what it's going to come down to when I'm done designing is there's going to be 1, 2, 3, 4, 5 parts that will need to be printed. The inlet and the exhaust, obviously, they're actually just the same thing, interior wise, as well as the caps. You can take the cap off and turn around and do it that way if you want to put the air in one way or the other. Same thing with the bottom. So right now we're just working on getting some. What the heck does he have me get it? Sorry, go ahead.
So what are you using to drive this thing? Like, these small holes in the middle. Is that where your
Yeah, the rotors will go, or the axles and rotors are going here. I don't have those set up yet. I'm still working on those. I have to print out a lot of them, and then I ordered some Lexan plastic that we're going to work on cutting, because you can get a lot more accurate flat discs from Lexan than printing. Because I don't know if you can see on this thing, there's still some imperfections when you try and print this thin, and that causes instability and a lot of vibrating and stuff that you don't really want to have in your axles and rotors. So we're going to cut the Lexan, which is going to be perfectly flat, and then have spacers in between, and it'll all be nice little rows instead of this wobbly gobbledygook that you get when you try and print stuff out.
Well, that's kind of like even in these companies like Boeing and that, even when they print the stuff out, they still have a machine shop where they have to fine tune the stuff, and get rid of the imperfections of that.
Yeah, there's still some spacing issues in here. I have to print I think I have to print a flange to create a little bit more friction type fit, because right now this just kind of slides on and off. I'd like to have it grip a little bit harder. Might have to just put some grooves for zip ties or something to help hold this thing together a little bit tighter for when you start putting some high pressure into it.
So you haven't actually run this yet, right?
No, I just finished printing this stuff off and getting the rotor set up. I've got some bearings on the way, and then the Lexan should be coming in early December, and I don't know how long it's going to take to cut all those pieces, but it's going to take a minute to cut all those pieces.
Lexan is plastic, right?
Yeah, Lexan. It's really, really strong plastic, and Jeremiah has used it for a number of his turbines, and he says you can really get the RPMs up there, which we tested my previous version, not this one, but the one after it, and he was able to get it up to safely close to 8,000 RPMs, which isn't exactly high, but it's good for 3D printed.
So, and you're not planning to use this for like a gas turbine or anything like that, right?
There's
not using the plastic you want it.
The plastic is just for rapid prototyping. It's to get the basic design figured out and the dimensions all nailed down, ideally before you go into something a little bit more serious.
Yeah, like I do know that the Jake Bassell, he was he felt like once they got to perfection, then they could have like pressed ceramic, I think it was nitrate, some kind of nitrate, but they could have a pressed one, and that they could get the superheated materials at that point.
Yeah, but the way the dimensions are on this thing would be like a ton if we wanted to go out of solid materials. So it might be a candidate that's good for 3D metal printing, just because the inlet and the outlet and the exhaust and the spacing, the internal spacing volume, it's a lot. And if that whole thing was solid, this thing would just weigh an absolute ton. So there's voids that I've put in there for 3D printing, and that can be copied for 3D metal printing. So I think that would be the goal.
Yeah. So have you made any of these pipes? The twisted pipes that Tesla talked about?
I don't know about that just yet. I'm still kind of a beginner at all this. So Jeremiah is kind of like the guru who knows anything and everything about putting everything together and making it work properly. And I'm just kind of monkeying my way through things here. To
improve the flow of the materials, first I had like a valvular conduit, and it was like kind of like a twisted pipe in a way, to facilitate the cyclonic action of moving material.
Oh yeah, that's beyond me. That's beyond my knowledge.
Well, if you get a chance, get Jeff's books on Tesla turbines. He'll have it in there. Yeah.
Yep. Well, I'll jump off. Thanks for having me on. Just so I show everybody what's going on.
Well, thank you for sharing. And is there anyone else who want to come on up here? Anyway, I just want to encourage everyone. Be sure to, if you get a chance, go check out and possibly get signed up for these videos on demand from this year. Mike is supposed to be working on a way where you can gift them to somebody, and I hope he does that soon, because that'd make a great Christmas gift. A lifetime access to the 2024 conference. And I'd like to comment here that our DVDs, that we do have, does not have all the material that's on the live stream, because on the live stream, between speakers, Karen and Jason were out there interviewing people live, for the stream, so it wouldn't be dead, So there's a lot of material up there that you're not going to get anywhere else, So it's a pretty cool thing. Plus, if you want to help us out, it's Christmas time and we could use the help, And I'd like to promote the t-shirts once more. But most important is the YouTube channel. Be sure to go up there, check it out if you haven't already. At least subscribe. Subscriptions are free, and every time I put up a video, it's announced through the subscription channel. Okay, and if you want to join and see everything, it's $9.99 a month, and I know every dollar counts. And that's where we're at right now. And so, thank you for coming. And I'll see y'all next week. And don't forget to give us that the thumbs up, and I've got kind of stuck. Okay, give us the thumbs up and let people know that we had a fairly decent show, and hopefully I get hold of Bernard and he can be back on next week because he has a lot to share with us, And with that, got a couple more comments. Okay, I want to remind everybody, if you want to get the Kipper plans here, don't forget to drop me an email at steve@teslatech.info. Okay. Steve@teslatech.info. Just drop me a line and I'll shoot you one off. Okay. And you'll have a good night. And I'll see you all next week. God willing.